Talk about some applications of magnetism, and the first one we want to talk about is the electromagnet. And we've already actually talked about this when we mentioned the inductor. So that if you have a coil of wire and then you attach that to a battery, then what's going to happen is it's going to set up a current in the coil, and then that in turn is going to make a magnetic field. You can make a electromagnet by taking a wire, wrapping it around a metal nail, and then attaching it to the battery. You don't have to have the nail, but the purpose of the nail is it intensifies the magnetic field that you're creating. So an application of the electromagnet is like in a junkyard, where you might have a car, and you take the electromagnet and then you turn on the electricity, turns this thing into a magnet. You can pick up the car, move it over, and then when you turn off the electricity, it's going to drop the car. So there's an example of an electromagnet. Also, electromagnets are used like in doorbells. Now let's talk about the Earth's magnetic field. So if we draw a picture of the Earth, first of all, the Earth has a spin axis. So the axis that the Earth is spinning around. So spin. And then it also is going to have a magnetic axis. So the magnetic axis of the Earth is tilted with respect to this. So this makes a 23-degree angle with this line right here. That's the spin. And then about another 5-degree angle is going to be the magnetic axis. And so this is where the magnetic field is coming out, and then the magnetic field is going back into the Earth. So we want to know what is causing the Earth to have a magnetic field. And we've got two possibilities. So there could be a magnet inside the Earth. That was the original theory, that inside the Earth was a giant magnet, and then that would attract a compass needle. The other possibility is there could be a electromagnet inside the Earth. So it has something to do with electricity. Well, this theory, the idea of there being a magnet inside the Earth, won't work, because we found out that if you increase the temperature on a magnet, it loses its magnetism. And so we know that inside the Earth it's way, way too hot in order for that to happen. So that it's not due to a magnet inside the Earth, so that leaves us with this theory up here, that it has to do something with electricity. Okay, now we said that in order to make the electromagnet, you needed the coil. So material had to be going around and around in the wire. So can you understand why materials would be going around and around inside the Earth? Okay, it's because the Earth is spinning. Okay, then remember, the wire is made of metal. So are there any metals inside the Earth? Yes, there are. It's iron and nickel. And do you remember we said that both iron and nickel can be turned into magnets? So it's working out pretty well that it has something to do with electrical materials going around and around inside the Earth. But, and as far as I'm concerned on the exam, that's as far as you need to go. You should say that it's in the outer core of the Earth. So the Earth has an inner core, then the Earth has an outer core, and then the Earth has a mantle and a crust. So it's going to be the outer core where the magnetism is going to be created. The inner core is like the nail. So up here, when you put the nail in there, it intensifies the magnetic field. So the inner core of the Earth is like the nail that intensifies the Earth's magnetic field. So for purposes of the exam, if you say iron and nickel in the outer core going around and around because the Earth is spinning causes the Earth's magnetic field, that's going to be fine. However, it's not quite right because the Earth actually is what's referred to as a geodynamo. And so what that means is if you've got iron and nickel that's going around and it's going through an existing magnetic field. So let's say you've got a magnetic field that's pointing like this, and then you've got materials that are made of metal and they're traveling through that magnetic field, it causes electricity. But what do we know about electricity? It creates magnetism. So the magnetism creates the electricity inside the Earth, which creates the magnetism, which makes the electricity. And this is called a geodynamo theory, and you can look this up on the internet if you want to. Now the picture that is in the upper right-hand corner shows the magnetic field inside the Earth. So notice that outside the Earth, it looks pretty normal. So it's coming out and then going back in. And incidentally, this is a south magnetic north up here, and then this is a magnetic north down here. And the reason for that is, like if you've got a compass, the north end of your compass is pointing north because it's pointing towards the south end of another magnet. So what we normally call the north pole is actually a south magnetic pole, and vice versa. Kind of interesting. But if you look at the magnetic field inside the Earth, you see it's all tangled up. And the reason for that is that in addition to materials going like this, around and around because the Earth is rotating, you have materials that are going up and down at the same time because of convection. Heat rises, and as heat inside the Earth rises, it carries material up with it. So it's kind of like trying to go around and around and at the same time go up and down. So the magnetic field gets really, really tangled inside the Earth. And eventually it gets so tangled it snaps. And when the magnetic field snaps inside the Earth, north becomes south and south becomes north. So if you had a compass, your compass needle would flip, and the compass needle would actually be pointing south instead of north. It doesn't affect the spin, so the Earth would still continue to spin as normal, but the magnetic field of the Earth would reverse itself. And so if you're interested in that, watch my videos on geology. And then another interesting thing about the magnetic field is it also affects the atmosphere of the Earth. And so it causes the sun's solar wind and particles coming from the sun are going to be deflected by Earth's magnetic field. And what happens is those particles come in on the northern part of the Earth and they come in on the southern part, and then that's the auroras. So the aurora borealis, when these particles hit the atmosphere of the Earth. And so it's a good thing that the Earth has a magnetic field because that protects us against the solar wind. You'll also notice in that picture there that there are areas out here and areas out here where the particles that are coming from the sun get concentrated. And these are called the Van Allen radiation belts, and they're very dangerous. So it concentrates the solar wind here and here. And so if you were an astronaut and you were passing through this, you would be irradiated. And so the NASA was very, very worried about this when they sent astronauts to the moon, because they had to pass through that Van Allen radiation belt. So they put extra shielding into the capsule. However, there was a group of astronauts that went through the Van Allen radiation belts, and they were irradiated. And they didn't have the shielding, and when they came back, one of them was so irradiated that he caught on fire. Another one was so irradiated that he turned into a rock-like creature. Another one was so irradiated that he was able to stretch out his arms for long distances. One was so badly irradiated that she actually became invisible and had the ability to project force fields. Who am I talking about? Fantastic Four. It's true. So if you read the original comic books, that's the origin of their powers. Okay, so don't watch the movies. The movies are incorrect. Really drives me crazy. Okay, so let's take a break, and when we come back, we will talk about a MRI and how it works.